Hey there. I'm having sound issues. Hello? I think that worked. Yeah, okay. Sorry about that. We are in Unit 2, Lesson 3. It's our second lesson about writing equations to model relationships. And here's where things can get just a little bit sticky. So take your time watching the video and make sure you take lots of notes, okay? Because notes are important. All right. Let's use patterns to help us write equations. I love patterns and so many things. I love patterns because patterns just help math make sense in my mind, and I hope that they can in your mind also. So let's do this little warm-up here. Here is a table of values. The two quantities, x and y, are related. What are some strategies you could use to find a relationship between x and y? Brainstorm as many as possible. So what are some things, strategies you could use to find a relationship? Looks like for one, I have 0, 3, 8, 5, 24, 7, 48. Like, what is the relationship between x and y? Is there an operation? And when we use the word operation in math, we mean, like, is there a plus, minus, multiplication, or division that we can do to x to get y? Like, can we do something to x to get y? How is the x value changing? It looks like I'm doing plus 2 to each x value. Like, how is that changing? And then the y value, it's not really a plus 8. I don't know what it is. Okay? Looks like it's not linear. When I say that, I mean I can't add to it. But maybe I can do other things. I see that 24 divided by 8 is 3, but 48 divided by 24 is 2, and 8 divided by 0 makes the world explode, so none of that works. Erasing is very difficult. It's like I want to erase, I'm showing that I'm doing the erasing motion, but very little happens. All right, so we try to find the pattern. I look at a column, I look at just the x's, and that was easy because I can see that it's just a plus 2 in between each number. I look at the y's and I just don't know what it is. Let me check something. Nope, that's not it. All right, we can plot the x and the y's, which I think we see in the next slide. We do. Okay, I can plot 1, 0, 3, 8, 5, 24, 7, 48. I can plot them, and I can see if it looks familiar. Like this right here is curvy, which could be a squared function or a number to an exponent function, exponential growth, which we'll talk about. I'm not sure what other things we can do. So I'm definitely a plus 8. And then 24 minus 8. Ooh. Plus 16. I wonder if this one is plus 32. Nope, 24. That didn't help. I don't see it. Let's see. When y increases by 2, or sorry, when x increases by 2, y increases by 8. All right, let's move on. I think I figured it out. So 1 squared equals, let's move my head, 1 minus 1. 3 squared equals 9 minus 1. That was a tough one. And I love puzzles. 5 squared is 25 minus 1. 7 squared is 49 minus 1. I feel better though. I hate it when I can't figure out a puzzle, and I don't often give up. So it's really, what we see here is y equals x squared minus 1 is the shape of this graph. Okay? All right, so let's do the next activity. I believe your student task has all of this filled in. For some reason, my PowerPoint did not. So I'm gonna fill it in really quick. So give me a second. All right, the instructions say to describe in words how the two quantities in each table are related. Okay, so I'm going to use words and maybe write down a few things, but you can write down my words as you hear me. So table A says the number of laps in the meters run. So it looks like I'm running 1 lap, 2.5 laps, 6 laps, I don't know why I'm drawing arrows, and 9 laps. And each time I run another lap, I increase my meters. So if 1 lap is 400, 2 laps would be 800, a half a lap would be another 200, which is 1,000. Okay, 6 laps would be 400 each lap times 6, which is 2,400, and 9 laps would be 400 each lap times 9, which is 3,600. So the more laps I run, the more meters I run. All right. The number of home, meters from home. Okay, another typo. Okay, meters from home and meters from school. So meters from home and meters from school. The distance between home and school is 400 meters. I can see that here. Meters from home is 0, meters from school is 400. So if I'm at home, it's 400 meters to school. If I'm at school, it's 400 meters back home. Every meter traveled away from home, so as my meters away from home increase, my meters from school decreases. And it looks like these all add up to 400. Okay, pretty cool. It's getting pretty messy though, sorry about that. Electricity bill in dollars, and total expenses in dollars. So it looks like the electricity bill is this column. And then the total expenses, it looks to be about 400 plus the electricity bill. Yeah, 400 plus the electricity bill. 400, I should write it like this. So it looks like the 400 in this one is a constant. That's interesting. Again, I want to erase. There we go. And that last one, Monthly salary in dollars and the amount deposited in dollars. Ooh. It looks like the salary minus the amount being deposited. Sorry, the salary minus 400 is how much is being deposited. So maybe 400 is their spending money, their grocery money, their fun money. So you get your salary, you take away $400 and you deposit the rest. Okay, so let's look at that. It looks like I added 400 to each electricity bill to get total expenses. Looks like I subtracted 400 from each monthly salary to get the amount deposited in dollars. Here, it looks like I'm doing 1 times 400, or the number of laps times 400 equals the meters run. And then here, it looks like meters from home plus meters from school will always be 400, right? Electricity bill plus 400 equals total expense. And then monthly salary minus 400 equals amount deposited. So I think I just wrote 4 equations for those 4 tables. That's pretty cool. Hey, look, we're going to write 4 equations. So 400 plus x equals y. I think that is the electricity one. Equation 1 goes to table A. Nope. This is table A. That's table B. This is table D. And this is table C. Let's see. Yep. Okay, you can go back and look, but you've also taken notes. You have the paper right in front of you, and you can look there. All right. So again, we're looking at relationships, and we're trying to come up with some equations. The table represents the relationship between the base length and the height of some parallelograms. Ooh. Base length and height. Both measurements are in inches. What is the relationship between the base length and the height of these parallelograms? Base length and height. It looks like these are a +1. And it looks like this is decreasing. Ooh, no. What is the relationship between the base length and the height? All right, let's erase that. I'm erasing. I wish there's like a lasso button. Is this fun to watch? I think it's quite annoying. So from here to here, base length and height. 2. My base length is 3. My base length is 4. My base length is 6. It looks like as base length gets bigger, height gets smaller. We can go there. That's all I'm coming up with so far. As our base length gets bigger, our height gets smaller. I like that one. So yeah, as our base length increases, our height decreases, but not by a steady amount. All right, so far that's the only relationship I have. Okay, let's try something else. Visitors to a carnival are invited to guess the number of beans in a jar. The person who guesses the correct number wins $300. If multiple people guess correctly, the prize will be divided evenly among them. Okay, what is the relationship between the number of people who guess correctly and the amount of money each person will receive? We're going to pause that for a second. I just figured this out. Sorry, my mind was working in the background. Base times height. I have to move my head again. Base times height is 48. Base times height is still 48. Base times height is, check your calculator, 48. Base times height is 48. And base times height is 48. So the cool thing here is base times height is 48. That's the area of your parallelogram. And that's the relationship, okay? I'm glad I figured it out. Because again, I get really frustrated when I can't figure something out. And I try not to give up. All right, so here we have visitors to a carnival, okay? What is the relationship between the number of people who guess correctly and the amount of money each person will receive? Well, if we just do a basic, like if there's only one person, they receive $300. If there's two people guess correctly, $150. If three people guess correctly, $100. If four people guess correctly, $75. Yep, $75 a piece. So what am I doing here? Okay, the amount of dollars each received by each winner is 300 divided by the number of winners. All right, so we can say the amount that each person gets is $300 divided by the number of winners. And that's our equation. That's my relationship, which is the equation. I could also say the amount each person gets times the number of winners is 300. Okay, this one usually makes better sense to me, but you're going to get answers using either equation because the equations are equivalent. All right. A 1/2 gallon jug of milk fills 8 cups, while 32 fluid ounces of milk fills 4 cups. So what do we have here? Relationship. 1/2 gallon fills 8 cups. And then I have a 1 gallon fills 16 cups. So this would be 64 ounces. Let's draw this a little bit better. Let me erase that. Okay, so I erased it and I started to take some notes. So a 1/2 gallon of milk can fill 8 cups. Okay, that's actual cups, like a measuring cup. Well, 32 fluid ounces fills 4 cups. So I wrote here 4 cups is 32 ounces. So 8 cups is double that, which is 64 ounces. I asked Alexa how many cups in a gallon, and she told me there's 16 cups in 1 gallon. So if I double 8, I get 16. So I've got 16 cups in 1 gallon equals 128 ounces. I just doubled that one, right? So if I multiply the number of gallons, fluid ounces equals the number of gallons times 128 ounces. Okay, so I have a 1/2 gallon, it's 64 ounces. If I have a 1/4 of a gallon, it's 32 ounces, etc. Okay, so that really is my relationship. So fluid ounces is the F, is the number of gallons times 128 ounces, and that'll give you your total fluid ounces. I didn't like that one very much. All right, which quantities vary and which remain constant in each equation? So here we have base times height is 48, or height equals 48 divided by base. All right, which ones stay constant and which ones vary? All right, this is the important part. So things that vary are things that change. Okay, that 48 doesn't change. So that is my constant. And if we go back to that table, we notice that the base and the height, those columns changed for everyone, but 48 was always 48. Here, this was the amount made with the number of people that won. The 300 always stayed the same. That's my constant, where the amount of the people won and the number of people that won changed every time. Okay, same here. The fluid ounces, those are my variables. The amount of gallons is a variable, but 128 ounces is the constant. All right. All right, last bit. In the lesson, what were some of the strategies you used to reason about the relationship between quantities and to write an equation to represent that relationship? We looked at the data and we tried to find a pattern, okay? Sometimes, what did I do? I took a break from that problem and then I went back to it when I figured it out. So we tried to find the pattern. Here's another example. A student starts a new semester with $30 in their lunch account. Each lunch at school cost $1.75. What's the relationship between the number of school lunches purchased, N, and the dollar amount in the account, A? So A is going to decrease. So we have N times $1.75, however many that equals. And I'm going to say 30 minus that much is going to be how much is left in the account, because we start with 30 and we're subtracting $1.75 for each lunch. A chef is pouring oil from a large jug into equal-sized jugs. This table shows the relationship between the number of bottles used and the volume of oil. Okay, so the number of bottles, fluid ounces per bottle. Okay, it looks like I might be doing some division. Yep, I have 72 ounces. Divide by 3 gives me 24 fluid ounces per bottle. Same amount divided by 4 gives me 18 ounces per bottle. 72 divided by 6 gives me 12 ounces per bottle. 72 divided by 8 gives me 9 ounces per bottle. So 72 divided by B is going to give me the number of ounces per bottle. So which is the constant, which is the variable? Okay, the constant's the 72, all right? And the variable is the number of bottles. So I can use words and equations to describe the patterns I see in a table of values or in a set of calculations. When given a description of a situation, I can use representations like diagrams and tables to help make sense of a situation and write equations for it. Our glossary has not changed, and we are done for the day. Good job.